add the 2, carry the cubic root of pi, divide by the p from PEMDAS, integrate the area around the quadratic formula for all gamma in gamma, and boom, contradiction, QED. I have finally finished creating the most elegant proof in mathematics. Oh, hey, well, since you're here, you want to know what that was all about? No? Because you don't like math? Oh, then we gotta do something about that. Hello everyone, welcome to this channel that I'm deciding to call A Story of Mathematics. ASOM, for short, because it kind of sounds like awesome. Well, the reason why I'm calling it that way is because what I want to accomplish is to build mathematics from the ground up with you guys. I feel like in math classes, not everyone's in the same place as far as what they know of mathematics. You know, some people know this much, some people know that much. So what I want to do is I want to make videos where we're all in the same page. Now, if you're thinking, well, I'm not really good in mathematics, I'm not sure I get it. Well, actually, you are my target audience. You're the person I want to come in this journey with me. That's part of the reason why I'm saying that I want to start mathematics from the ground up, from the beginning, if there even is a beginning. From my years of tutoring mathematics and teaching mathematics, I've noticed that there's a common misconception about what mathematics is. People think that it's about doing steps, following steps. Um, and maybe from the education K through 12, that might be kind of the case. But in reality, mathematics is not about that. Um, it's about making arguments, about explaining why something's true, something's not true. And I guess if you're not a math major, which again I'm assuming you're not, you won't really understand what I'm trying to say, unless maybe you come in this ride with me, please. You know, give mathematics a chance, please. So what do I mean by math is about making arguments, talking about true or false statements? Well, let me show you something real quick, right? The biggest pet peeve that your math teacher is going to have is if you write something like this: a plus b parentheses squared equals a squared plus b squared. Or another popular one, which is basically the same thing: a plus b cubed is a cubed plus b cubed. So the problem with this statement, you can say that this equation is a statement, is that it's not always true. Uh, it might be, it sometimes is true, but it's not always true. And in mathematics, a statement is only true if it's 100% of the time true. So yeah, even though you might think this is how things should work out, this is incorrect. Well, now that I made this mark, now it's correct, right? This is not equal to that 100% of the time. I mean, we'll talk about this later, but a plus b squared is going to be equal to a squared plus 2ab plus b squared. Again, in the future, we'll show why this is so. It's not that hard. But yeah, you see the plus 2ab is missing, and that makes all the difference, because with that plus 2ab there, now this statement is true 100% of the time, right? So again, in the future, try not to do try not to do this, right? Okay, so again, you might be doing algebra, and again, where's the statements, right? Well, let's say that you have this equation, 2x plus 8 equals 14, right? Right. So you're saying that 2x plus 8 is one quantity itself, and it's equal to 14, right? So what do you do to solve this? Well, usually a lot of people do this, right? They subtract 8, which at this point you're actually saying that these two things are equal, and you're subtracting by the same amount, so the end result should still be equal. 2x equals 14 minus 8 is 6, right? And then at this point, maybe you think, oh, the next step is divide by 2, which is the same thing as multiply by 1/2. And then 1/2 times 2 cancel, you end up with x equals 6 times 1/2 is just half of 6, so 3, right? Which again, you're saying if these two quantities are equal, if I cut them both in half, they should still be equal, right? So even though you're not saying that in sentences, in words, you're kind of making an argument why we start here and then the end is this, right? But again, mathematics really isn't about steps. Although you might think what we just did were steps. Well, someone else could be doing the same exact problem. 2x plus 8 equals 14, right? And then they might notice, well, 2, 8, 14, they're all even numbers. So I can cut them all in half, right? So maybe their first step is to divide by 2, which again, same thing as multiplying by 1/2. Now in this situation, it's a lot more clear that if you multiply by 1/2, you got to distribute it. Again, we'll get, if you don't know this, we'll get to it in the future. But it just means, again, multiply by 1/2 just means cut them in half. So yeah, if I cut 2x in half, I should just have 1x. And if I cut 8 in half, I would just have 4. And if I cut 14 in half, I'll get 7. And then yeah, now one very logical step is to subtract 4. Again, subtract the same quantity from both sides. So now in the x equals 7 minus 4 is 3. And again, right, we ended up with the same correct answer, x equals 3. Now, this is what I mean by, this is what a lot of people say, you can do math all different ways, but as long as you're doing it correctly, you will get the same answer, right? Well, again, yeah, just to kind of generalize that is, as long as all your statements are truthful, then yeah, you should end up at the same spot, right? But again, this idea about steps, see, I mean, if you have 2x plus 8 equals 14, and you say, okay, how do you do it? That no one ever really mandated you how you should always do these steps. I mean, maybe some teachers did, but there's actually some freedom in mathematics. Now, what I mean by, again, do a correct step, true statements, false statements is, so again, suppose that, again, they notice that all the numbers are even, so they want to divide by 2, right? And yeah, a lot of people just make it into a fraction. They just go like that, right? They divide by 2. And a common error that a lot of people do is that I don't know, they see this divided by 2, right? And then they only divide one of these two numbers by 2. So the two numbers in question are 2x and 8. And again, most commonly people only divide the x one by 2. So in this case, 2x divided by 2 would just be x. And then for some reason, they completely forget about that you should also cut the 8 in half, right? And over here, cut the 14 in half, you get 7. And then again, you subtract the 8. X equals -1, right? So again, now we found an answer that was not the previous answers, because the error happened between here and here, right? So again, here the error is that indeed 2x plus 8 over 2 is not equal to x plus 8. This is the you could say the error, the false statement that kind of tainted the whole mathematic process here. Now, just to clarify, your teacher, suppose you do the problem the first way, right? Your teacher isn't necessarily looking for you to write, for example, 2x plus 8 equals 14, and then say, subtract the 8, and then that's where you have 2x equals 6, and again, say divide by 2, and then now x equals 3. Again, when I say that methodology, your teachers aren't really looking for this. They understand. They can look at what you do here, and they're going to be okay with that. The key thing is that your teacher can follow the logic that you did. So, for example, if you show this, this does show exactly what you were doing. The teacher can tell what you were doing. Even if you do this, the teacher can still know what you were doing. In this case, your teacher can still know that what you were doing, and then they can catch the error, right? So, just so you know, if when your teachers tell you to show work, they mean that what you write should make sense. Hopefully, you don't just write everywhere, 2x plus 8 equals 14. Hopefully, you don't, do random stuff, and who knows what you get, right? You never want the teacher to be guessing what it is that you did. But it's not, so yeah. Again, showing work is not just about that it should be shown neatly. But again, I'm telling you, your teacher is looking that what you wrote makes some logical sense. So that, in a nutshell, is what mathematics is. Since this is my YouTube channel, I will take the liberty of giving my own definition of what mathematics is. From my whole experience dealing with mathematics, I would say that mathematics is the art of finding new truths from already established truths. You can look up the dictionary definition of mathematics, but honestly, I looked at it, and I felt it was very arbitrary. I feel like it doesn't really convey what it is to be a mathematician, even if you're like an amateur mathematician. But if you're willing to go on this ride with me, maybe by the end of this ride, you'll see what I mean. So don't forget to subscribe, maybe like the video, but more importantly, tell people about it. I really do hope that I can make a difference as far as how you view mathematics, to the very least. Oh, and as a bonus, you might get to see what it is to be a math major. Just in case, maybe you're still in high school, you're deciding what major to take, and you're thinking, math was pretty easy for me, I'll try to be a math major. Well, I want to show you what it really means to be a math major, but that will be way into the journey. Alright, goodbye.